Good afternoon, everybody. We will continue our discussion on source coding. There are many kind of source coding that is used for various kind of data, depending on the types of data. So we will discuss just a few, maybe some classical ones like Huffman we have discussed. Similarly, we will discuss one more, arithmetic coding, though nowadays it is not so popular, but it's a classical lossless coding technique. So we'll discuss it, and then we may discuss a little bit one or two other kind of source coding before going to channel coding. So like Huffman coding, arithmetic coding is also based on the probability of occurrence. Probability of occurrence of symbols or data. However, unlike the other coding technique, arithmetic coding gives a single number. It produces a single number. Single real number. It can be a decimal or binary number. If we use the representation of polarity probabilities in binary fraction, then the resulting number will be a binary fraction. If we use in decimal, then it will be in decimal fraction. So the coding depends on the resolution of the final number. That's the coding information. Is embedded in the final number. Now let us take one example. Just like before, we will take a probability table. Let us take 4 symbols. A1, A2, A3, and A4. And the message suppose let us take a message. Okay, let us take the message A1, A2, A3, A4. So A1 has a probability 0.2. A2 say 0.2, A3 0.4, and A4 0.2.
So in this message, isn't each of them 0.25?
No, the probability, okay. The probability of occurrence this symbol is A1 is 0.2. Okay, this is the probability table. This is the probability table is given by this one, A1, A2 probability table. And then a part of the message or the message we are sending is A1, A2, A3, E4, A4. Okay. So this is can be thought of a part of a message or a message. However, we have a probability table estimated based on the occurrence of large number of A1, large number of A2, and large number of A3, and large number of A4. So basically, we have assumed that we have not computed this probability table from this message to be transmitted. Rather, this has been estimated based on the occurrence of A1, A2, A3, A4, maybe for a certain interval of time or for a certain interval of set of symbols. Okay, this is often the case in case of Hoffman also, though we have taken one example initially to show that how to compute the probability from a string, but generally one cannot compute probability of a small string. That can be done for a tutorial exercise, but when we implement, so generally these probability tables are either a static table estimated for a considerable longer time or a longer number of occurrence of symbols such that more or less it is steady. So then we store that as a probability table. Now the probability table can be refreshed time to time. So based on another, based on the change of in the probability table. If there is if the change is quite significant, then the probability table will be refreshed. In case we use adaptive probability table. If we use fixed probability table, then the probability table is estimated for a fixed durations. Say if we are transmitting over a channel, transmitting some data from a source at a data rate of 1 megabit per second, then probably for a certain time, maybe for a day or two, something like that, or even people do it for a longer duration as well, and estimate the probability table. Often this probability table is refreshed for a source in a periodic manner. Okay, because if we make it data dependent, then if the data size is quite large, like say that is possible in case of image or other kind of video data, where the traffic load is quite considerable. So in such cases, we can make a probability table specific to that particular entity, and then can transmit that probability table. Because at the decoder end, we have to know the probability table to decipher, to decode the source data. So therefore, the probability table need to be transmitted. If we do it for a small string, so therefore the overhead, bit overhead for the probability table transmission will be quite considerable compared to data. So therefore, that is not profitable, though we may achieve some coding efficiency in the source, but because of this requirement, that may not be that much profitable. So, so in this case, we have assumed that the probability table is given by this probability table, okay? And we currently are transmitting a small segment of data A1, A2, A3, A4, okay? Now, this could be, say, now we make the probability intervals in cumulative fashion. So we start with the start of the message. So the first interval is 0, 0.2. Then this is 0.2, 0.4. Then 0.4, 0.8. Zero 0.81. So basically the 0 to 1 interval, we make an initial interval, and then subsequently we will update these intervals. So this initial interval we put in one side. Zero to 1, 0.2 A1, 0.2 to 0.4 A2, 0.4 to 0.8 A3, I think and this is this interval 0.8 to 0.1 is A4. So basically these are the intervals. Now we will expand each of these intervals in the same ratio. So first 0 to 0.2 interval is partitioned in the same probability, same fraction. This is 0.2. So 0.2 multiplied by 0.2 is 0.04. Then this is 0.08. This is 0.16. and this is 0.2. So this interval 0.16 to this one is A4, A3, A2, and A1. Then the next interval.
That's what did you do from that initial interval to this one?
0 to 0.4, 0.4. Basically, because we are compressing, we are making sub-intervals in the interval of 0 to 0.2. Okay, so that means we are embedding this probability distribution, that is 0, 0.2, 0.4, these cumulative probability distributions in the sub-interval of 0.2. So because the distribution is intact, they themselves can represent the symbols A1, A2, A3, A4. Okay. So so next we do the same thing for the next interval. So next interval is highest is 0.08 and lowest is 0.04. Okay. So 0.08 multiplied by 0.2, so that is 0.016.
So this also will divide in that same ratio, right?
Yes, yes, in the same ratio. This will be divided in the same ratio. So basically, like that, it will, sorry.
Be 0.048, right? The first one.
This one is 0.04 and second one is 0.04 plus that
0.04, which is 0.048.
0.048. This one is 0.56. This is 0.07. So next, this interval. This is 0.072. This is 0.056. So next, the last would be, the last interval can be, A4 can be so 0.072. We can either make it this interval, or we can make this one would be twice, because this has twice the length. So we will make it twice. So then it becomes 0.068. This becomes 0.006. So the last interval would be 0.068 to 0.072. Or if we make it further, the final interval which is 0.60667.
So that interval which we are expanding is going in upward directions one by one. No?
Yes, upward direction.
So then
starting from 0. Okay.
Then in this one and the last which was expanded, so both are in the middle
Yeah,
one, like.
because here there are two divisions, 2.2 divisions are there. So that's why we are doing it twice. Okay. And actually, because we have 4 symbols, up to this 4 times is sufficient to give the precision of a number which can be represented, which can represent the message A1, A2, A3, A4. So the intervals are successively divided. To narrow down to a final interval sufficiently resolved in decimal places. Zero point 0.688, 0.06752. So now the message can be any number between this interval. In fact, the can be any number on the upper interval as well, that is between 0.068 and 0.072 had it been resolved further.
So how did we get 0.688? There's only 1 8, no?
2 8.
2 8. So difference in 2.2 subtracted from 0.072.
Okay,
So
this is 0.068 is as a 88. Okay, this is 88. Sorry, I mistaken.
So
This must be 88.
what is like
Yeah, I have made this. This one is 0.0688. Okay. So between this interval, any number can be chosen. The message A1 A3, A4 can be uniquely represented by any number. Between from this interval. say for convenience, we take just we take up to 3 decimal place. Had it been, suppose we have an interval which is maybe coming up to 1 decimal place and all other becoming 0, like say, had it been like 0.0100 to something, then we could not have taken 0.01 because the precision has to be sufficient to go up to the 4 places. So here 0.068 will have that property. At least 3 decimal place is required to represent the 4 symbols.
So we need to go to the top level in this, right? Is it like compulsory? That's the rule, right?
Yes, which one?
Like so we were dividing our lowest interval, then we're moving
Achha,
upward.
we are going from lower to top. Actually, most of the algorithms are doing like that. Okay. So we could do other way as well.
So do we have to go till we reach the top, or can we stop until we've got a sufficient number of decimal places?
You know, we have to go up to the top. Okay. Or at least the number of messages. So here we have done this one twice, so 4 times we have done. Okay, so that's why we have stopped there. Now, had it been the message is 5 or 6 length, then we have to go 6 times, 7 times like that. Okay, I mean number of symbols, it depends the number of symbols in the message.
So sir, we need to perform this process for number of symbols present in the message, right?
Yes, yes. So
sir, like in that process, even if we don't reach the top, it should not matter.
yeah, top would not matter. Top would not matter. I mean, you are telling that this 0 to 1, which I could not understand. Top does not matter means?
And so like even if we don't reach like 0.0712 like that.
Yeah, no, but finally we have to decode, no, because we have the information only of the probability table in the decoder end. So we for the encoding part we can do anyway, but and in the decoder the sequence is that 0, 0.2, 0.4, 0.8, 0.1. So we shall see how do we decode. Okay. So this is encoding. Yeah.
The interval from 0.4 to 0.8 was like, you were saying we did that 2 times because its width was double, right?
Yes, yes, yes. So that's why we have done twice.
So if happening only once, like if the widths were all equal, if it was 0.25, 0.25, 0.25, like that.
No, in this particular case, it is like that. It may not be always like this. Okay, because ultimately we have a probability table. There could be 0.1, 0.3, 0.2, something like that. Okay. So
But like here we had a case where 4 of the cases were 0.2 and the one case was 3 cases were 0.2 and one was 0.4. So we knew that 0.4 case happened twice, so we could do it twice. But like
yes,
it may
yes.
be very nice. Like sometimes if we have
Yeah,
one,
it may not be so. So it could be easily done for this case. Other cases we have to explicitly do it all the steps. Okay.
like
Like
so if
say,
it was 0.1, so it was literally 0 to 0.14 and then 0.14 to let's say like 0.29, like the
yeah,
interval not of multiples of each other's length. So then how will we divide the number of steps?
we will take up to the decimal. Okay, so here it is up to 1 decimal. Here we are going up to 2 or 3 decimal, and next we will go up to 4 decimal or 5 decimal. Next we will go up to 5 decimal or 6 decimal maximum. That is sufficient. More than that, those decimals are not required to represent this many symbols. Okay, so because the placeholders in the decimal places are basically representing the number of symbols. So that's why in the interval we can choose any one, barring that if there are something like in this interval there is no such number. Okay, because it is starting from 0.0688 and ending 0.0752. Had it been like 0.0600, okay, we could make a number something like 0.060 because it is in that interval. Okay, so but that would not have been sufficient to represent the 4 messages. So that is one choice need to be made while choosing the unique number from that interval. Because in the decoder part, again, we have to go through that route. So therefore, point 068 is taken to encode. So therefore, this is the number. Now this can be make binary by simply multiplying 2 successively. So there will be binary stream created. Of course, the problem is again that after when we are going on multiplying by 2, so in many fractional numbers, it may not represent a whole binary number.
Sir, also one thing, while starting the making of intervals, we start with that message, whatever the message is.
Yeah, that is the message.
Okay, sir.
So at the starting we are told that this will give us a unique number, but then here it is written that like, any number in that interval would.
Yeah, any number, a suitable number need to be chosen.
So now it is unique because like any number would work now. So
Yeah, generally for exceptional cases, some number, say for a 4 symbol, it may result into 2 decimal places, something like that. But generally, it does not happen. For exceptional cases, it may happen. So, however, it will be at least 3 decimal places
okay,
because
so like in
we have
general
successively divided these intervals 4 times. So therefore, this number will be, if in that interval, it will be up to, at least up to 3 decimal places. Because here, this is a real space. So we are starting from 0.06752. So there is a whole number 0.068 is coming in between. So that's why we have taken here. So now this need to be represented in binary form, binary fraction.
okay, so
to transmit. So after it makes at the decoder end, what will decoder will do? The decoding is done similar fashion of encoding. So first is we will start from the beginning. So first check step 1. check which interval supports 0.068. So if we go here, 0.068 is supported by the fund. Okay. So therefore, that is A1.
So what intervals are we checking?
This interval 0 to 0.2.
The
Okay.
initial intervals.
Yeah, initial. We will go initially. So in the decoding,
Sir, you are not audible.
yeah, 0.068 belongs to the first interval.
Sir, I have a confusion here. So the interval which we have made, like A1, A2, A3, A4, this is we have made by looking at the message signal, that is A1, A2, A3, A4, or these are the symbols.
Yeah, message signal only. The sequences in the message signal, but these are point 2, point 4 are given by the probability table. Suppose it is A2, A1, okay. Then we have A2 is also 0.2, so that will also 0.2. But suppose A3, A1, then first interval would be 0 to 0.4. Okay. Had it
Okay,
been
sir. Okay, sir.
A3, A1, then first interval 0 to 0.4. And then it is cumulatively divided. Now for the decoding part, so first we check, so this gives.
But if we had taken A3, it would have been 0 to 0.4, but then shouldn't we arrange them in some fixed
No,
order?
in that case, the first symbol would be A3, no?
Yes, sir.
In
Like
that
here it
case,
is given as
in,
like 0.2, 0.2, 0.4, and 0.2. Like, should we not first arrange them in some ascending or descending order, and then?
no. Yeah, that is one of the difference. Yeah, I should mention that. Here, that ordering is not necessary. Okay, it is ordered in the event as the message symbols are occurring in the message. Okay, so it maintain the order of the.
So it is not necessary that the intervals will end at one, right? Because like some symbols can be repeated.
Yes, some symbols can be repeated.
Okay, sir.
So this gives A1 is the first symbol. Now we are here 0.068. So now we will make this one as 0.068. Okay. So we have to divide that as 0.068. And this is 0. So 0 to 0.68. Now this will, and we divide it. What would
So
be
first one, then 0 to 0.2. What did we do with that information?
Yeah. So that is first that 0.068 belongs to this interval. Okay. Now we subdivide 0 to 0.68 in the similar fashion, like this one. Okay, 0 to 0.6 is divided, this is 0.068 and this is 0. So therefore this is 0.0 So this will be 0.06 something will come. So in the second interval. So then this will be more than 0.04. So that way A2 will come here actually. So the second symbol will be A2. Similarly, we will go on checking the next interval. So then we will check that if we divide it, which symbol is checking, which interval it is coming. So that way A3 will come. Okay.
So and the interval is the name we write down as the message, right?
Yeah. So like then we have to do it. So A1 is the first symbol, 0.02, and okay. Now we are going so in the second step. Step 2. Belongs to the interval of A2. Between 0.04 and
Sir, from step 1, how do I know that it's A1 and not A2?
Because the first interval
But at the decoding
0.068 belongs to the A1 interval. In the second step, for the second message, we are checking the second stage. Okay. So basically, this is stage 1.
Sir, but even if I take A2, A1, A3, A4, then also will I not get the same encoding?
Sir, if the first message is A2, then we expand the second interval, right? First
Yes. So that way, this will not be A1, A2, A3, A4. A2 will come first, then A1 and A3, A4. Okay.
So it means from each of these stages, we just check which interval it comes into, and we just take the corresponding name of it as the message.
Yes. So next stage.
So, but like INT is already in terms of the actual message.
Yeah, it is in the order of actual message only.
But how will
So
that?
like, how will we know that the first interval from 0 to 0.2 is A?
That way we have done stage 1, stage 2, stage 3, stage 4, according to the message.
Okay, so the stage 1, stage 2, stage 3 is according to message.
Yes.
So this is making of the stages that is known on both sides, right? Transmitter and receiver, both sides.
Only probability table is necessary. Well, then stages can be formed once probability table and message available. So then it will be this sequence will be there. Okay. So only that need to be transmitted.
So could you repeat this now? Like what needs to be transmitted?
So we will transmit the sequence, binary sequence, and the probability table. Okay. So that means this interval also need to be transmitted, 0.2, 0.4, 0.8, 0.1. So this will be also transmitted.
But so this is like fixed, right? We did not take it from the message. because it was mentioned that would take more computation. So
Yes, yes, yeah, it will computationally, it is not that efficient.
it means table is already known, so only thing we're transmitting is this number.
Yes, that's why tables are like fixed tables are used to code messages, because otherwise this may not be an optimum case, or even overhead becomes more than the data. So step 3.068 belongs to A3. And step 4. So this way, but the main drawback is the way it is computed. But if you see the Hoffman also, we had to track all those probability tables, and correspondingly the codes are formed.
Step 4 is coming again to A3, I think so, because it was 0.0688 to 0.072.
Yeah.
Last stage, but this is less than 0.068.
0.068.
Is correct.
Yeah.
Okay,
It's
okay.
correct only, bhai.
Yeah.
No.
Yeah, that's fine. That's fine. Yeah, it's
that's
fine.
the last interval. No, last interval belongs to F4 only.
Yes.
So, but in this, why did we exactly do the expanding for A3 twice? Because like we even if we had done once, we would have found out, right?
To find a unique number. To find a unique decimal number. So that's why the name is arithmetic coding. So, however, as you can see, the methodology, implementation of the methodology for a long message is not very trivial. So therefore, it is not a very popular one. So that is one of the disadvantages of transmission of data using arithmetic coding. However, this also produces an unique and lossless coding scheme.
Sir?
Yeah.
Sir, I didn't get how we got A4 after A3.
After A3, we check here that where 0.068 is there. A3 interval, this is also A3 interval. Okay. Now,
So we will not check that one and check the next one.
yes. We check the next one because here we had twice actually. We have done twice. So A3 interval has met twice. So that's why, and next A4 interval has been produced in stage 5. So maybe we can write this stage 5, step 4. In stage 5.
Excuse me, sir.
Yeah.
Sir, please explain that segregation of probabilities in step 4, like.
No, because A3 is double this interval, so A3 has to be divided twice. So this is again the A3 interval has come. So that's why stage 4, instead of stage 4, in the stage 5 only we have gone to the I mean,
So we should have taken this interval 0.06 to 0.07.
Yes, we should not pick this interval. Even if we pick this interval, another A3 will come actually.
And
So
the
that's
signal
why
will be 183.
we are not picking this interval, because still we are dividing the A3 interval at this place. So that's why we are not taking it. So as you can see that the programming task is quite complicated. So the main problem is that for arbitrary probability,
So this doubt, so like the third stage was divided 2 times, like the third interval.
yes. No, first stage is 1 times only. First stage we have done 1 times. Okay.
One third one was done 2 times because it had twice the size.
Twice the individual sizes, so that's why we have done twice.
So if we take every stage, then the message will come A1, A2, A3, A3, A4. So how do we know when it is repeating, when it is not repeating?
No, because this one has the interval is of 0.4 length, so we have to skip 1. Okay, and then we go to stage 5. So in the final stage, only we will pick this interval of 0.068.
So how do we know how many to skip? Like, because what if the message is itself?
No, that has to be known from the probability table and how we are dividing the stages. Suppose had it been, it may happen that there are some arithmetic coding schemes that though the probability table is of 4 stages, they have even done a finer interval. So that means I can do it, say, at 0.1 interval, irrespective of the probability table, or maybe 0.01 interval, depending on the tables. For a big table, it so happens that these decimal places may come at, say, 0.82 or say 0.83, something like that. And so that way and in such cases, we may have to go for divisions, say 0.1 or even 0.01 for a large set of symbols. So then there would be many such states that we have to skip, because the symbols which are having higher probability may occupy, say, even 10 such states, I mean intervals, or maybe much more in a general programming scenario of large set of symbols. So that happens. That's why the programming is very tricky. For a, I mean, general scenario. Here we are doing with 4 symbols, and for convenience, we have taken all those, I mean, some good numbers. But in general case, actually, this has to be taken care quite judiciously. To make this coding efficient. So, however, we have discussed it, though it was not there in Heckins, but and some of the source other books it is there. So I have just introduced it, but it is not a very popular one. I think the next one we will discuss is a very popular code used some of the documents like PDF documents and other, and also very simple to implement, that is known as LZW coding, whose methodology does not depend on this probability distribution, but it depends some kind of occurrence of the symbols. So that we will discuss next, but today most probably we don't have much time.
Excuse me, sir.
Yeah.
So here from sender to receiver, we are sending only in the probability table.
No. Generally, as I was telling, that probability tables is a pre-stored table, which is an estimate of the occurrence of the symbols, estimated periodically. Say every month we have estimated that occurrence of A1, A2, A3, A4, and then that table is refreshed on the other end. The way, and then that will be used instead of transmitting every time the probability table.
Sir, so the
It is assumed that if n tends to infinity, this is occurrence of this A1, A2, A3, A4, those probability numbers will come to a steady number. Okay. So that is the assumption.
So, but the receiver has to know the order in which that chart will be created, right? Because A1, A2, all of the A1, A2 both have probability 0.2. Now, if it places A2 before A1, then it will detect A2 first, right?
Yeah, it will detect A2 first, but that way the message will be also transmitted.
The ordering
So
is
the
fixed.
order of
the way the message will be coded, okay, in the encoding end, that depends on the probability table. Okay.
Okay, sir.
Okay,
So like
the
in which
alphabets
order
we are
the
coding, here we are telling A1, A2, A3, A4, those are the 4 symbols. And ultimately in the other end, those symbols will be decoded. Each of them will be decoded.
Okay, sir. So only which symbols are present, that has to be decoded.
That has to be decoded at the other end.
Not the order. Okay. Okay, sir. Thank you.
So I think we will discuss just one more most probably, because already we have discussed, spent already 3 classes on source coding, so we do not want to discuss anything more. Maybe tomorrow we shall discuss a little bit about this LZW and finish this source coding.